Good morning, and thank you, Rob. We gave this title of the presentation for today, Accelerating the Adoption of Interior Monitoring Systems. We chose this title because that's basically what Euro NCAP has been doing for the past 25 years or so, and specifically the 10 past years related to active safety. This is our mission, try to make sure that OEMs receive an incentive to adopt technologies that are going to help driving safer. So I think this slide requires no explanation. Everybody knows what interior monitoring systems are. They are used to detect, classify, and analyze the occupant's state. It's a technology that is growing fast, and the past 5 years or so especially is becoming quite a thing and quite promising for the future of vehicle safety. I personally believe in the power of these systems to enhance safety and enhance safe driving. There are the typical risk behaviors we are already tackling since 2023, which are distraction and impairment. And these still are very high risk factors to address today and probably for the years to come. It's very difficult to understand how much of an impact these factors have by using traditional accident data. You really cannot understand very well most of the times whether an accident was caused by someone being distracted. Maybe no one will ever admit having been distracted while having an accident or after having an accident. But I think it requires really no further analysis in a world full of distractions. This is something that we need to tackle. And impairment keeps also being a factor of risk, namely drowsiness and driving under the influence are keeping things to tackle for us. We're going to have type approval mandates for this technology starting from July 2026. Everybody knows this. But at Euro NCAP, we are going to, as always, try to stay above and beyond regulation, trying to add our bit, trying to stay above regulation, what regulation requires, and provide an incentive. As you can see in this chart here, this is just maybe an overview of the adoption that these technologies have had so far across the vehicles we have evaluated over the past 4 years. I haven't included 2024 because it's a bit of a fresh data still, but in 2024 we can see sort of a similar trend as the one we saw in 2023, where more of the half of the vehicles we evaluated had direct sensing. Before I go forward, it's important to understand that in today's assessment, you can still have a 5-star vehicle without any direct sensing system. So it's not a must. It's something that you can utilize to enhance safety, but with the current calculation to achieve the 5 stars, direct sensing is not a must. So what's on scope for today's presentation? There are 2 main pillars, and those are what you see here, occupant monitoring and driver monitoring. These are going to be the 2 factors, the 2 pillars we are going to be addressing, or how we are going to call them from 2026. From January 2026, we are going to have new protocols, new requirements, and we are also going to have a new rating scheme, which I'm going to present right now. For occupant monitoring, we're going to focus on the presence of occupants, and specifically child and other occupants. We're going to address the correct belting of the seatbelt, understanding whether the occupants are out of position, and accordingly adjusting the restraint strategy on how these occupants are seated and what's the size of these occupants. And then we have driver monitoring, which is essentially what we do today, but with a bit of an upgrade, which I will go a bit into detail in the coming slides. So we address distraction, drowsiness and impairment, microsleep and responsiveness, And also for assisted driving, we have the driver engagement factor, which is becoming fundamental to address with these systems. I mentioned before the new rating scheme we're going to have in 2026. This is how it looks like. Essentially, we have 4 different stages addressing safety in 4 different stages. So first is safe driving. Then we have crash avoidance with the classical AEB systems and lane support systems. Then we have crash protection, that is essentially passive safety, and post-crash are the countermeasures that we want to have to address, to call emergency responders, for example, when you have an accident. But today we're going to focus in safe driving. Everything about today is going to be safe driving. And the 2 pillars I presented before are included in this stage. So it's occupant monitoring and driver engagement. This is a bit of the point distribution we are going to have for the safe driving pillar. I will not talk about points anymore during the slides, so this is the summary. And essentially what safe driving means is whatever technology that supports you in conducting safe driving, mitigating the risks, right? We have here a total of 100 points. So every stage has 100 points. Safe driving has 100 points. Crash avoidance has 100 points, and so on. For safe driving, these 100 points are split as follows. And you can see here that we're going to have a soft landing when it comes to achieving 5 stars. The threshold to achieve 5 stars across these different stages are going to be so that in every stage you are going to have to achieve a minimum number of points to get 5 stars. In 2026, in the safe driving box, you will have to, in the safe driving stage, you will have to achieve 60 points to get 5 stars. Then 2027 is going to be 70 points, and 2028, 80 points. And this is so to give manufacturers time to adopt these technologies moving forwards. So today we will talk about occupant monitoring and driver engagement. And up next, this is the detailed breakdown of points for occupant monitoring. Essentially, here we have seatbelt usage, occupant classification, and occupant presence. And I will go into detail on those areas. For occupant, so for monitoring of the seatbelt use, we have been doing this for a long time already. It's actually already mandated to have a seatbelt reminder. But what we are incentivizing manufacturers with is with what we do today. So it's rewarding the rear seat occupancy detection. So in how many of these seats you are able to detect that the presence of a person, of an occupant, and understand whether they are belted or not. And what is new in this assessment compared to this year is going to be what we call seatbelt misuse. So we want to prevent that. You could argue this is more or less common nowadays. I still see that some taxi drivers in some areas of Europe are misusing the seatbelt because of the frequency they are actually driving these cars every day. For convenience, they choose not to be belted on even, I don't know, this is a common issue with elderly that they don't see the sense in having the seatbelt on. So we are going to address 3 different use cases at first. This is going to be our first introduction. Systems that can detect and trigger an audiovisual warning when you already have the buckle. So you can buy this fake buckle in Amazon for a few euros, and you can essentially fool your seatbelt reminder. We want systems to detect that misuse. Whenever the seatbelt is completely behind the back, like in this picture, and when you're only using the lap belt, so when actually the chest belt is behind your back and you're only wearing the lap belt. And in 2029, we will populate this assessment with additional use cases. Moving forward with occupant monitoring, we have occupant classification, and we are going to, this is also a new use case. It's airbag deactivation for child restraint systems. And depending on what approach you have as a manufacturer to address this case, to deactivate the airbag when you put a child seat on the passenger seat, and then you get a number of points. If you can do this automatically, you get maximum points, and then you have two different approaches for system advice. It's a matter of convenience, really, so the more convenient it is for this airbag deactivation to occur, let's say, the more acceptance is this technology set to have, and the more penetration we can expect. So that's why we give more points for automatic, all the way down to manual, what is actually you having to step out of the car and switching the airbag off. And then we have out-of-position detection and information only for the passenger. And here we address these two use cases. So when the passenger is sitting too close to the airbag, to the fascia of the cabin, or when the feet are on the dashboard. So then the passenger needs to be informed. We say informed. You just need to have a message telling you that the position you have at this moment is definitely not going to be beneficial if you are involved in an accident. So we just want people to be aware of this, and we just don't want many warnings in the car, just an information that is displayed to the passenger or driver. And then we have status classification. So the introduction we're going to have here is that at least you're going to have to detect two different restraint. You're going to have two different restraint strategy settings, or two different restraint settings that are able to cover the three different percentile of sizes on the driver and passenger. So it's very basic, but it's a start. And actually, talking about that, this is the roadmap that we have for occupant classification when it comes to restraint adaptivity. So you see here that we want to go on the y-axis. We want to go all the way to the top. And today we are going to address the basic side of it. So having at least two different restraint strategies, two-stage load limiter, time to fire adaptivity. Up next, maybe 2026, we want to go to what we say advanced with multi-load limiter, multi-stage load limiter, vent adaptivity. And towards the future, towards the end of the rating of the Vision 2030, around 2032, we want to go to a system that has a limited adaptivity. To accomplish those levels, you are kind of forced to have different approaches for sensing. And we don't really care about which sensors manufacturers are using. We don't have to care about that. That it's the use cases, the ones that are driving actually which sensors you are going to have to equip your cars with, so that these strategies can be accomplished. So we have now the basic setting, which you can address with only the seat position. Then when we want to go to advanced, most probably you're going to have to go to direct sensing. So besides of the seat position, you understand what is the occupant stature and weight. That is important to have a good adaptation strategy for your restraints. And then for the complex restraint strategy, then you're going to have to be even more detailed on your sensing capabilities to address this use case. Child present detection, I'm not going to spend too much time here because this is a protocol that it's finished already for a long time. We don't expect any changes here. In 2025, so in a few months from now, we are going to start rewarding direct sensing only. Up until now, we were only receiving the dossier from the manufacturer, in which the manufacturer was explaining to us what approach was taken to detect the presence of a child. But from January 2025, we are going to use the matrix of different use cases that we have in the protocol. Audiovisual warning needs to be provided, and only direct system is going to be rewarded. And for the first time, we're going to have a surrogate, so a test dummy, a baby dummy, approved and certified to be using as a testing tool. And that's going to be introduced in a few months from now, January 2025. And in 2026, we can just expect exactly the same. With a different point distribution, maybe just adapting the current points to the new rating scheme, but when it comes to requirements, it's going to be the same. Oh, and I missed the post-crash presence. So that's a new element here as part of occupants presence, and that's simply we are incentivizing with points to manufacturers that can understand how many occupants are in the car in order to send this information to the emergency responders. So it's not where these occupants were seated, whether they are present or not after the crash, but only how many occupants are in the car at the time of a crash, and sending that information to the emergency responders. I talk about occupant monitoring, and now I'm going to switch gears to driver engagement, which is going to be focused on the driver only. And here we have two different clusters of driver state. We're going to call them like this: transient states and non-transient states. Transient states are all the states you can get out from within a matter of milliseconds or seconds after a stimulus, right? You are distracted, you go back to you draw back your attention to the forward road view. You can revert that state. Non-transient state are the states you can actually not revert unless you actually take a break or take a good rest and go back to having the situational awareness you should have when driving. And this accounts for 30 points in total driver engagement, out of which 25 are for driver monitoring. We have a separate assessment for driving controls, and I'm not going to talk about that today. And this is the detailed point distribution for the driver engagement. This is how the points are going to be distributed. So I'm going to give some time for you to look at it. And it's very hard to read, but I really didn't have to make it bigger, because maybe most of you are already well aware of the different gaze locations we have in the current DSM protocol, right? And the number of gaze locations for 2026 is not going to change. We're going to have the same gaze locations for the distraction case. The split is going to be the same, so gaze locations for long distraction, short distraction, or visual attention time sharing, and as a subset of short distraction, we have the phone use cases. What has changed a little bit here is what you see in green. If you can read it, I don't think so, but it's the advanced phone use case, in which the phone mounted on dashboard driver side has been switched from basic to advanced. And this is just to give an opportunity to OEMs to score points in the basic phone use cases, because we understood that the gaze location of phone mounted on dashboard driver side is very complicated to detect correctly. So we consider it's advanced, and you should get advanced points for that. So therefore, the basic phone use detection remains a little bit more, it becomes a little bit more accessible. So what's new here? Maybe the long distraction timing. This has been a matter of controversy in the past years. And we are trying to be quite careful here when it comes to striking the right balance between addressing a risk and keeping in place the nuisance interventions. So you could argue 3 seconds is too long, depends on the speed you're driving maybe. But experience has told us that 4 seconds is also okay, right? So we will give the opportunity to OEMs to have a timing of eyes off the road between 3 to 4 seconds. Now we are a bit more harsh when it comes to manufacturers getting beyond the 3.5 seconds if they have some latency to compensate with. Our target remains 1 second until 2026, 3 seconds for the 2023 assessment, but we're going to be more permissive here. We have forward collision warning sensitivity and link to ADAS. By the way, link to ADAS, I will explain in the last slides what we mean. This is new. And that is the vehicle response requirement. So an audiovisual warning when you detect a certain driver state, and the intervention strategy that an OEM chooses to have. We would like to have a more structured dossier when it comes to assessing and verifying that what the manufacturer tells us is correct. We are going to force them to report the true positive rate and false positive rate for monitoring purposes only. And as part of the spot check, well, we have spot check today on the test track in a very synthetic environment, to be transparent here, only on daytime. So we are going to expand this environment and go out to public roads and monitor some KPIs for the driving monitoring system while we drive around. This route is going to be used for other purposes like speed assistance, the assessment of speed assistance. Obviously, we need to go to the public roads for that, but we are going to take advantage of this route, of this on-road evaluation, to also assess other functions like DMS. And here we just want to understand how good the system is in the day-to-day drive. Because, otherwise, if you take too much of a progressive approach with these systems, I think others will talk about that during today or tomorrow. We need to be really careful with the adoption of these systems when it comes to usability. Moving on to driver, so non-transient states. I'm still talking about driver monitoring, and I talk about transient states, now talking to non-transient states. Here we have impairment, microsleep, and sleep. Today, impairment, we only have drowsiness. But in 2026, we're going to have two different subsets of impairment. We want to call it like this. Impairment fatigue-related, for example, drowsiness, sleepiness, fatigue. Different subsets, really very complicated to detect accurately. And non-fatigue related. So for the first time, we are going to give points to manufacturers being able to address this use case. So we're going to call it non-fatigue related. But you can imagine that this is really, everything that is not fatigue related is maybe you driving under the influence of some legal or non-legal substances. Here we're going to be quite open at first. I think we believe in the potential of technologies to address this, but it's for sure that OEMs are quite reluctant to this technology still. But still, we have to get the ball rolling, and we didn't want to wait 3 more years to address this very problematic aspect that still exists nowadays. For microsleep and sleep, we are talking about eye closure, 1 to 2 seconds for microsleep with prior buildup of drowsiness, and more than 3 seconds eye closure for sleep. And the vehicle response remains the same across the 3 different states that are here. So it's audiovisual warning and also intervention related. We talk about the link to ADAS that I will present later. For example, adjusting the sensitivity of lane support systems. The last non-transient state that I talk about is the unresponsive driver. We have this today, so we are going to keep the same approach as today. It's just that we're going to call it emergency function, which is a function that should start not later than 5 seconds after the driver has been classified as unresponsive. So unresponsive driver can be someone who is maintaining an eye closure beyond 6 seconds, or someone who is ignoring distraction warnings for 6 seconds. And the emergency response, emergency function, which is basically bringing the vehicle back down to a stop or standstill, maintaining the headway to the vehicle in front of you, and maintaining the position in your lane, or even stopping in a target lane, like an emergency area or the hard shoulder. That will be still rewarded. I mentioned before the links to ADAS, and I'm gonna go back to the new rating scheme that we're going to introduce in 2026. So occupant monitoring and driver engagement are in the safe driving stage, but it's going to have a link to crash avoidance. What this means is that the premise is that traditional crash avoidance systems is only effective when it can prevent assistance or performance when it's relevant, right? In many cases, especially with lane support systems, most of these interventions are not relevant. Unless you're falling asleep or you're not paying attention to the road, lane support systems are going to annoy the hell out of you. But for the first time, we have the opportunity to link these systems and to adjust the sensitivity of ADAS according to the state of the driver. This is, in a nutshell, what we want moving forwards. We have two different areas here, frontal collisions and lane departure collisions for this link. When it comes to frontal collisions, we can talk about forward collision warning, emergency, automatic emergency braking. And you can see here a lot of different cases that you can encounter in the day-to-day driving, where you have a small overlap with the car in front of you, or a crossing pedestrian or a crossing bicyclist is actually quite on the edge. It's maybe a near miss, and on those near misses, you're going to have an intervention most surely with today's intervention strategies for collision avoidance systems that are going to be considered not relevant if you're paying attention to the road, if you have the situational awareness you should have, right? And so here, essentially, we want to be linking the driver state to the intervention strategy for those systems. So these situations, you could argue they are unjustified. If you're paying attention, you should not have an AEB intervention or a forward collision warning on those situations. Same goes for lane support systems. I mentioned it before. In this kind of roads, for example, very common in the Netherlands, you can see them everywhere. If you're driving above 60, which is the typical operational speed of a lane support system, beyond 60, you're going to have interventions or heading corrections from the lane support system all the time. Here you have to go to the road edge a bit when you want to avoid a vehicle coming head-on and give space to it. You're going to have to go back to the center when there is a cyclist, and the lane support system is going to be intervening all the time. These systems, to be clear, they have a huge life-saving potential. We should not ignore the life-saving potential of lane support systems. They are there to help you, but only there to help you when you're drowsy or you're not paying attention. So this is what we want in a nutshell. I think this is my last slide, and this is a disclaimer. It's a message that we want to give from Euro NCAP to industry in general. As a manufacturer, you are doomed, really. You are doomed, as manufacturers are doomed today for lane support systems. You will be doomed in 2026 when these systems are mandated if you don't keep this balance in place. I wanted to illustrate it with this diagram, which is, I think, fundamental to understand. In the yellow band, you have a 5-star vehicle configuration. You need to have a certain sensitivity for your ADAS system, whatever ADAS you can talk about. You need to have a minimum sensitivity to achieve this 5-star configuration, but you don't need to go all the way to the right side. You don't have to do that. Of course, that is going to ensure that you have a good performance in the test track, but as a result, you're going to have a decrement, or you're going to have specificity being increased. So that means the risk of false positives or nuisance interventions while driving on the road are going to be massive. So please be careful. This is the message from Euro NCAP, because we do not give points according to the false positive rate that you have as a manufacturer. We just assume we understand that manufacturers are smart enough to keep this balance in place. We don't have we don't have any way to actually assess and test this condition. We test for specificity, we test for sensitivity for the true positive rate, but the other side of the story is really on your hands, and please keep this balance right. Like I said, especially when this technology is going to be mandated from 2026, and we can expect chip systems to dominate the landscape. So I hope this makes sense, and please keep it in mind. This is our message from Euro NCAP. So that's the summary. We're going to address seatbelt use, airbag and restraint detection, and optimization of restraint strategy, still keeping the child present detection as one of the things to address. providing the right information to emergency responders after an accident, and leveraging the technology of in-cabin monitoring systems for the safety benefit these are bringing, and making ADAS interventions smarter. So thank you very much.
Thanks, Adriano, for the great presentation. Obviously, Euro NCAP at the heart of driving safety, so really great to understand what's coming up in the future. I know we're a bit over time, but I also know you're here for the content, so we will take a quick question from the audience. Haley, up at the centre there. So just a reminder, we'll have coffee after the next presentation, and then we're back in this room for the rest of the morning today.
Thank you, Adriano, for the great material. Just a question regarding the post-crash presence. Could you please elaborate if it's just counting number of occupants and whether there is an overlap with the seatbelt reminder, if it is valid for every seat? Wouldn't be an overlap there?
You could argue indeed that we are going to give double points for that. But it's not only that we are detecting the presence of occupants with the same strategy that you do today for seatbelt reminder. It's that is not going to be rewarded, right? So we count the number of occupants, but you need to use robust sensing to accomplish that. Yeah.
Okay, I'm afraid we're going to have to wrap up in the interest of time, but Adriano is around for the rest of the conference. Please find him during the coffee breaks and continue the discussion. Thanks for a fantastic presentation. Cheers. Thanks.